So today we're looking at historical counting systems. We'll look at changing bases. Then we'll take a quick look at a Peruvian counting board, and we'll look at a Mayan counting system as well. And the previous class, I think this lecture took about 45 minutes. So the good news is, hey, we're out of here in 45 minutes. The not so good news is, then we're ready for test 2. So let's talk about an everyday normal number. Say, let's do that. 2,327. We can think of this as 2 times 1,000 plus 3 times 100 plus 2 times 10 plus 7 times 1. Right? Same thing. Add it all up, you get the same thing. Well, 10 or 1,000 is simply 10 to the third power. 100 is 10 to the second power. And 10 is 10 to the first power. And 1 is 10 to the 0 power. Because anything to the 0 power is 1. So we can apply these principles to different bases. And the process is the same. So let's look at how this works. We're going to convert a binary number to base 10. So I'm looking at a base 2 number. I'm going to convert it to base 10. So let's simply write this out this way. 1, 0, 1. We go from left to right, top to bottom. Now this here is times 2 to the 0 power. And this is times 2 to the first power. And this is times 2 to the second power. Just like we did here. So this is 1 times, and 2 to the 0 power is simply 1. This is 0 times 2 to the first power, which is 2. And this is 1 times 2 to the second power, which is 4. So now we can do our multiplication. Add it up. And this in base 2 is 5 in base 10. Now, a couple things to note. If we're in base 2, none of the digits that we use will be larger than, or will be equal to or greater than 2. So everything has to be less than 2 if it's base 2. Just like in our number system, each digit is less than 10. Okay? So let's look at another one of these. Same principle. I have 1, 0, 1, 1, 0, 1. And I'm base 2, so I multiply by 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and 2 to the fifth. So this is 1 times 1. This is 0 times 2. This is 1 times 4. This is 1 times 8. This is 0 times 16. And this is 1 times 32. That's 32, 0, 8, 4, 0, 1. And we get 45. Any questions on how this works? Yes, it is a little tedious. Practice will make you better at it and quicker at it. And yes, you don't have to show all these steps. I do it because I'm showing you how to do it. Once you get comfortable with it, you can skip some of the steps. Any questions so far? Ready for the next slide? Okay, here we have another base 2 number that we're going to convert to base 10. Same process. Left to right, top to bottom. 1, 1, 1. 0, 0. 1, 0. And again, we're dealing with base 2, so I have 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, and 2 to the sixth. This is 0 times 1, which is 0. This is 1 times 2, which is 2. This is 0 times 4, which is 0. This is 0 times 8, which is 0. This is 1 times 16, which is 16. This is 1 times 32, just 32. This is 1 times 64, 64. Add them all up, and what do we get? 114. And note, when we have a base 10 number, we don't have to put the base. Anything else you do. So any questions about going from base 2 to base 10? So what about going the other way? Everybody got it? So we're going to convert 45 to binary. Same principle. 2 to the 0, which is 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. And 2 to the fifth, 32. 2 to the sixth is 64, so we don't need to go there. So I'm starting with 45. How many times will 32 go into 45? Anybody? How many times will 32 go into 45? 1. Okay, and 1 times 32 is 32. Subtracting, I have 13 left. How many times will 16 go into 13? 0. Very good. How many times will 8 go into 13? 1, so that's 8. Now I have 5 left over. How many times will 4 go into? 1. It's repetitive, isn't it? How many times will 2 go into 1? And 1 goes into 1. Well, it's kind of repetitive since there's only 2 possible digits. Then we go down, go left to right. 1, 0, 1, 1, 0, 1. And don't forget the base. Because if that little 2's not there, that number is 101,101. Because base 10, we don't put the base. Every other base we have to. Any questions? Everybody got the page? Okay, so now I have 126. So again, I have 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32, 2 to the sixth is 64, and 2 to the seventh is 128, which is too high. So looking at 126, how many times does 64 go into 126? You got a 50-50 chance of guessing. 1. Leaves me 62. How many times does 32 go into 62? Leaves me 30. Next digit. How many times 16 go into 31? Leaves me 14. How many times did 8 go into 14? Somebody else want to answer the next one? How many times will 4 go into 6? 1. This is tough, isn't it? How many times will 2 go into 2? 1. I'm all out, so this must be 0. Again, going down is going left to right. 1, 1, 1, 1, 1, 1, 0. And don't forget the base. It's easy, right? Well, it is. It's all the same. Just using different numbers. So let's see how it works with a different number. How about convert 486 to base 8? So it's the same setup. 8 to the 0 equals 1. 8 to the first equals 8. 8 to the second equals 64. And 8 times 64 is what? 512, so that's too high. So I start out with 486. How many times will 64 go into 486? It's not 1 this time. And remember, it has to be a number less than 8, because we're doing base 8. 7. The 7 times 64 is what? 8, 40, 448, is that right? So I have 38 left. How many times does 8 go into 38?
4.
And you are allowed to use your calculator on this. How many times does 1 go into 6? And I have 7, 4, 6. And don't forget the base. Any questions on how we did that one? Not hard. It does get tedious. Everybody got it? Scream now or forever hold your peace. And now we're going to look at base 3. Gonna mix it up a little bit. So we have 3 to the 0, which is 1. 3 to the first, which is 3. 3 to the second, which is 9. 3 to the third, which is 27. 3 to the fourth is 81. What's 3 to the fifth? 81 times 3 is 243. Now I have 273. How many times does 243 go into that? Now I have 30. How many times does 81 go into that? Now I have 27. I didn't do it, I promise. 9. 3.
1.
Nothing left over, so I have 1 0 1 0 1 0 base 3. Definitely want to put the base there because it could be easily mistaken for base 2. Any questions converting base 10 to base 3? It's all the same thing, just in different, with different numbers. Move to the next page. Okay, now we're going to look at converting from other bases to base 10. Same process. Going across, go down. 4, 5, 3. We're doing base 6, so that's times 6 to the 0, times 6 to the first, times 6 to the second. So this is 3 times 1, 5 times 6, and 4 times 36. Now this is 3, 30, and what's this, 144? This gives us 177. Again, we're base 10, so we don't have to put the base. Any questions? Yes. Because base 10 is understood. That's the base we use. When you write a number, do you put base 10? No, because it's understood. That's what, if there is no base there, it is base 10. That, which is why it's very important that you don't forget to put the base on the other bases. Okay, so now let's do from base 8 to base 10. So again, 8 to the 0, 8 to the first, and I'm going to need some help on this one. So this is 5 times 1, 1 times 8, 6 times 64, and 3, what is 8? Excuse me, what is 8 to the third? 8 times 8 times 8. You are allowed to use your calculator.
512.
512, thank you. So 5 times 1 is 8, 1 times 8 is 8. What is this? 360 plus 24 is 384. And 1536. Somebody want to add that up for me? 19, is that 1933? Or 1946? No, 1933?
19.
Simple, right? Everybody's going to ace this part of the test. Just think how quick the homework will be. Ah, now we get letters. You have any computer people? Hexadecimal. Big with computers, or it was in the past. Back in the before Windows times. So we have a base 16, but unfortunately, I only have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I only have those digits. What do I use for the other digits? Well, let's start with the alphabet. A, B, C, D, E, F. In this case, A is equivalent to what we would call 10, B 11, C 12, D 13, 14, and 15. Nope, we do not go up to 16. So now it's just the same. So I have 7, I have D, and I have E. Well, I might want to translate this to numbers I like. So 7 and D is 13 and E is 14. This is times 16 to the 0, 16 to the first, 16 to the second. Now this is 14 times 1, which is really easy. This is 13 times 16. This is what, 208? This is 7 times, what's 16 times 16? At 256. Times 7. Somebody want to help? 14, 17, 50, 1792, is that right? Do I still know how to multiply in my head? 2014, and again, we've converted to base 10. So we don't put the base down. Okay, we have another one here. Actually, I want to keep that so we can refer to it. So I have C 6, 7, 9. And C is 12. So this is times 16 to the 0, 16 to the first, 16 to the second, 16 to the third. So this is 9 times 1, which is 9. 7 times 16, which is what, 112? 70 plus 42. 6 times 256. What is that? 1,536, is that right? I'm doing this in my head, don't trust me. Somebody check.
It's 1536.
And this is 12 times what? Is it 4096? 16 cubed? Is that right? So what's 12 times that? And then we add it all up. 50,688, 900. 51,009, is that right? Six 19, 6, 8, 9 now. 5, 6, 7. Is this right? That's not what we got last time. Somebody add those up for me and see what we get.
5,809.
That was close. Anybody else got that so that we can confirm?
Yeah.
Okay. So again, use your calculator. You're allowed to use it. Why not do it? It's very easy to mess up doing it in your head or even writing it down and doing it. And if you're allowed it, why wouldn't you? Okay, so now we're going to go the other direction. So we had 16 to the 0, which is 1, and 16 to the first, which is 16. And what was 16 to the second? 256. And then 16 to the third was 40,000. So that's not going to help us. I'm looking at 493. How many times will 256 go into 493? 7, 3, 2. How many times does 16 go into 237? More than 10, right?
14.
14? Which gives me what? 226, is that right? 224. That was close. And then, of course, I think 1 goes into 13, 13. So now we have to go back. This is 1. 14 is what? A is 10, B is 11, C is 12, D is 13, E is 14. 1 E D. So 1 E D to the 16th, base 16. Don't forget the base, or else I'm going to think you think education is number 1. Okay, one more, and then we'll move on to the next topic. So again, converting to hexadecimal.
From the last roll, you did shift the letters over 1. So it's actually 1 in D, C.
1 ED. Go down, go across. Right? Did I make a mistake?
14 is supposed to be D, D13 is supposed to be Z.
13 is D, 14 is E.
Yes. It's that.
When in doubt, write it out. Hey, that rhymed. I'm a poet and didn't know it.
Yeah, I wrote it out wrong.
You gotta be careful. So now I have 16 to the 0, which is 1, 16 to the first, which is 16. 16 to the second is 256, and it looks like 16 to the third will go in there as well. So how many times does 4,096 go into 9,455? 2, right? At 8192? Is that right? Check my math, because I've become a math teacher because I was lousy at math. 256 goes into 1,263. Is that about 5? No, I think it's gonna be 4, right?
Say 4.
Giving me what? At 1,024? And 16 goes into 239. Oh, gee, what was this? 14, which gives us 224. Leaves 15. 15. So this is simply 2 and 4. And 14 was E. 15 must be F. So 2, 4, E, F, base 16. So any questions about changing base? Going from one base to the other and back the other way. If the base is anything other than 10, make sure you put it down there so I know. And now we'll get to the fun stuff. Peruvian Counting Board. Need to go back?
Yes.
Yes? Did I go too fast?
Just don't go to that one second.
It's not that bad. It's not that bad. Did you actually need to see this, or do I?
Want to see the other one?
Why?
I don't like them.
Did you read about them? Then how do you know you don't like it?
I don't like them.
That reminds me of what I told my parents. I don't like this. When they were trying to give me some funky looking food.
I attempted them.
And you know what they told me? How do you know you don't like it if you haven't tried it? And I just used the old George Carlin line. It came to me in a dream. It's easy. It's not complex. This is actually a 3-leveled board. You had the white on the lower level, the gray on the second level, and the darker gray on the third level. And this is how this works. Real easy. Anything you find in this block, this block, this block, this block, this block, this block, this, and this counts as 1. See? Easy. Here and here counts as 2. I'm sorry?
Why are we making puzzles?
It's not a puzzle. Is it gonna be on the test? Why? Is it hard? Sure it does. You gotta remember, these are people that didn't write.
Well, they should have learned.
Well, the Europeans hadn't made it over here yet to teach them.
I'm not gonna be a coder. You know this.
These areas count as 6. This is part of your well-rounded mathematics education. Yes.
Where does the 4 and 3 go in the 5?
There are no 4, 3, and 5. Well, there is a 3 actually right here.
Yeah, but we need to know
Why do you need it?
why is the 3 part bigger than the 6 part?
Why not?
Got those little dark gray boxes.
I'm getting there. I keep getting asked questions that, why is the sky blue? Does anybody know? Because if it was green, you wouldn't know when to quit mowing the lawn. 12 and 12. Not that hard.
I think 22.
I'm sorry? Now here's how this works. You have the following counting board with 2 different kinds of pebbles. Yeah, they didn't write, they had pebbles. We'll let the solid. I'm sorry?
Your pebbles and give them pencils.
They didn't have pencils. Had inkwells and feathers.
Well, that'll work.
And as I said, the Europeans hadn't made it here yet.
So, it's right.
I'm sorry? They used pebbles, it was lighter. So we're going to let the solid black pebble represent a dog and the striped pebble represent a cat.
Dogs don't look like that.
Their representation. Now let's see how many dogs and how many cats we have. And we'll start with dogs, which are the solid black pebble. So looking here, I have 2 in a 1 square. That's 2 times 1, which is 2. Then I have 3 in a 2 square, which is 3 times 2, which is 6. Then I have 1 in a 3 square, so that's 1 times 3, which is 3. Then I have 3 in a 6 square, so that's 3 times 6, which is 18. And then I have 1 in a 12 square, which is 1 times 12. 12, add it all up, and I get 41 dogs. See, that's easy, right?
Remember, are we gonna have that diagram on the like last?
Hold on a minute and I'll answer that question. First, I want to finish this. So now let's do the cats. Okay, here's 1 times 1, which is 1. Don't have any in my 2 spots, so here's what? 6 times 3, which is 18. I have 3 in my 6 spot, so that's 3 times 6, which is also 18. I have 2 in my 12, so 2 times 12 is 24. And I have 61 cats. What do you need a pencil for, a dog and a cat? You gonna write instructions, sit? No. So I'm guessing nobody wants to do another one. Is it that bad? Is it really that bad? Well, you see, the problem with it is it takes up too much space. So it's not on a tab. But you'd know that if you looked at the homework.
Yeah.
So, who's familiar with the Roman numeral system? Got it pretty good? So do I, because it doesn't make sense.
Like I-V-V-I.
Because we go like this, 1, 2, 3. Where the heck did they get that for 4? Yeah, well, why couldn't you do this?
Yeah, I don't know.
Then it gets bizarre. Where the heck does that come in?
Yeah.
And then what's next? Let's see. What is 50? Anybody remember what 50 is? It's L, isn't it?
50's L.
If you're a football fan, you know that, right? Super Bowl 55.
I didn't know that.
And then there's C, which is 100.
I never made it past it.
And then I think there's a D for 500. And then there's an M for 1,000. You see that in the, when you see copyright dates, MM and then a bunch of other letters
That's great.
for movies and stuff. So you understand that? Well, some of you did. You raised your hand. So this is easier. We're learning historical counting system. I could have been mean and put the rope knot stuff on here too. That would have really blown your mind. Then I could bring a rope in and tie it and say, what's this? And you have to put it on the test. I might do that next semester. This that'll be the last time I teach this, I think. So. This is real simple. Any oval shape is 0. I've seen it 2 or 3 different ways. I've also seen the dot solid or open. So you go 1, 2, 3, 4 dots. That's 1 through 4. When you get to 5, you go to a line. Then you start adding dots. Then you go to a second line. Then you start adding dots. Then you go to a third line. Then you get up to 3 lines and 4 dots, which is 19. So what base is this? 20. So, trivia question. Why do we use base 10? Very good. I don't know that that's actually true, but it makes sense. So why would the Mayans use 20, base 20? They didn't wear shoes. Again, don't quote me on that. So this is how this system works. So let's see if we could figure this out. Because the table takes too much space. And really all you need to know, 0, 1, 5. That's all you need to know. Right? So what's this? What's this? Base 20. 20 to the 0, 20 to the first. 3 times 20, 13 times 1. 13, 60, 73. Easy, right? Yes? No? Any questions? We've got a couple more. It is on the test. Although I think I do it the other way. I'm not sure anymore. Been so long since I've looked at the test. So let's look at the next one. Hey, there's yet another way. So what's this? It looks like a football. It's, and then here, and there. That's times 20 to the 0, times 20 to the first, times 20 to the second. 3 times 1, 0 times 20, 3 times 400. And I don't know who put this in here. But that's my phone number. Not telling you the rest of it. I don't mind emails in the middle of the night, but phone calls. Any questions on how this works? Because they used base 20, the Mayans used base 20. Everything was in 20. A year was 360 days. Which is probably why we didn't have doomsday in 2012. Because they were shortening the years. You're welcome. Okay, second to last one. So what do we have here? Looks like two smiley faces and an eyebrow and some monster looking at you. So what's this? What's this? What's this? 0 times 20 to the 0, 0 times 20 to the first, 10 times 20 to the second, and 12 times 20 to the third. 0 times 1, 0 times 20, 10 times 400, 12 times 8,000. 96,000, 4,000, 0, 0. That looks much funner than this. So one last thing I want to look at with this. Let's convert the base 10 number to Mayan. Because it's there. And we write out our bases. I think we can stop at 3.
On the homework, you're gonna use convert to base 10, from base 10 to Mayan.
Is there a problem like that?
Yeah.
Okay, which probably means there's a test problem like that. Because that's usually how it works. So how many times does 8,000 go into 52,127? You're allowed to use your calculator. I'm going to say 6. So how many times does 400 go into 4,120?
10.
How many?
10.
10? Are you sure? How many times does 20 go into 127?
6.
6.
Close enough.
7. Does it have the convert to base 20 first and then convert to Mayan on the homework, or is it just convert to Mayan?
If I remember correctly, it's convert to base 20, then to Mayan.
Okay, so this would be A, so we'd have 6A, 6, 7, base 20. Okay, so I'm looking at 6, 10, 6, 7. How do I write 6? How do I write 10? How do I write 6? How do I write 7?
I mean, you know, Mayan's not come back one day.
Convert it to base 20 and then.
Okay, yeah.
Convert it to Mayan.
So what do you think? That's not too bad, is it? Heck of a lot easier than all them Roman numerals that we had to learn in what, 3rd grade, 4th grade? I'm sorry? They're not teaching that anymore? Shame on them. How are you gonna know what year a film was made? So here's the issue we have. That's everything for test 2. 2 chapters. So this is for the in-class people. Thursday the 12th. We'll go over the study guide. And of course, what that means is starting Friday, I will only check for completion and not accuracy on homework. Tuesday and Thursday, the 17th or the 19th, exam 2. So again, you can come either day. So what this means for those of you that are online is that those 2 days we will not have any live lectures. For those of you with accommodation needs, I believe the original test date was the 19th. So you will need to make your appointment so I can send them the information. Are there any questions?